So the first poll we had was, do we think that greenhouses are using less energy than indoor cultivation facilities? And we see that that's interesting. It's about just slightly over half, okay? So the next one that we're going to have is about light. Higher lighting watts per square foot correlates to higher PPFD, higher light received by the plant canopy. And the last one, more light equals more yield, greater yield. Okay, about 2/3 disagree with that one. Oh, nope, 70%. Okay. Thanks for coming, and I'm going to let Nick introduce himself and just take it away. Is that okay? Okay. Thank you, Nick.
Thank you. That was quite the setup, because it sounds like I have all the answers, which I do not. And these questions, of course, it's all dependent, right? Where are these greenhouses, et cetera, et cetera. So the data I'm going to present is a set of data. It doesn't necessarily represent everything, but it is based off of a minimum of 1 year's worth of 15-minute electric interval data, monthly fossil fuel consumption, if they consume fossil fuel, and a year's worth of production data in terms of dry, usable product. So it's a decent data set. I'll start with that. So how much energy is used in cannabis cultivation facilities is the first question I ask. And so this is a plot of what we have found in a recent study. So what do we see? Annual energy consumption along the bottom, the x-axis, and that's all fuels. Annual production on the y-axis, and then again, that's dry usable product. And we see, wow, really tight correlation here, right? R squared of 0.96. People familiar with R squared values, what that essentially means? It basically means that the dependent variable, how much production you make, is incredibly tied to how much fuel you consume. So the 0.96 means that there's an extremely strong correlation between these two things. So maybe that's not too exciting or profound in and of itself until you consider that this data set includes indoor, mixed light, brand new construction, retrofit, a couple thousand square feet up to over 30,000 square feet, fossil fuel heat, electric heat, and vertical stacking. So all of that is represented in this data set, and yet we still have this incredibly tight correlation between total energy consumption and total facility productivity. That to me is pretty interesting and not necessarily what we expected going into this. So what is driving that energy use? Well, we find that there is a pretty strong correlation between the lighting power density and the total fuel consumption on the y-axis. So we go, okay, so lighting power density is driving consumption of energy to an extent at these facilities. All right, well, what's the deal with lighting power density? How does that impact production? Well, this is odd. Why is our production going down as our flower room lighting power density goes up? What we are finding here that is not reflected, but we know from the project details, is the facilities with higher lighting power densities had the fixtures mounted way up high. So they had to mount way more fixtures in order to get the PPFD that they're looking for at the canopy. The facilities with the lower lighting power densities, not only did they have lower overall annual energy use, but they had better, more consistent PPFD. I say better, more uniform PPFD across the canopy. So again, not something that we would have necessarily expected to see here. But lighting power density and PPFD, they're related, right? I don't think so. The poll says no, people didn't think so. And that is reflected in the data as well, right? So lighting power density and PPFD, not related. Again, why is that? It's how you're mounting these fixtures. So right away, this tells me that we've got some issues in terms of lighting design in these facilities. There's something we can do right off the bat just by changing the layout of the existing fixtures to improve the light delivery in these facilities. But PPFD and production, those are related, right? Surely there's a correlation between PPFD that everybody wants so badly and production. No, there isn't. What's going on here? So again, you can see that we've got PPFD values down around 700, and those facilities are still producing on the order of 350 grams per square foot of flowering canopy. Then we have facilities all the way out at, what is that, like 1,100 PPFD that are making about half of that, right? So what is this? What do we learn here? What does this tell us? Does it mean that PPFD is not important? No. It means that it's not everything, exactly, right? So what remains? If it's not PPFD, what else is it? What remains? What is driving the production in these facilities? If I hear them, yeah. We heard CO2. What else did you say, Nadia? CO2, temperature. Yeah, yeah. Genetics, yep. How about just cultivator skill, right? Because we saw multiple facilities in this data set that were all but identical on paper. HVAC system's basically the same, lighting's basically the same, PPFD's basically the same. One facility is literally producing double the output of the other facility. So to me, there's a lot to be learned in terms of best practices, cultivation techniques, and then what are those strain-specific impacts on energy and energy efficiency. So this is food for thought, right? This doesn't necessarily give us all the answers, and it's definitely not something that we could extrapolate out nationally to every single facility. But this is a solid data set that we have, very carefully reviewed and analyzed. And there's not much to interpret here. This is not based off of modeling. This is just straight up utility data and production data. So how is the energy used? This one's going to be fun, I think. Indoor. What % of indoor energy use do you think is associated with lighting, horticultural lighting? Just yell out some numbers. I didn't hear any of those. I heard 40. I heard 60. All right. What about that? That seems like a lot, doesn't it? We were surprised by this. This was more than we had anticipated for these facilities. Natural gas use really quite low. That's a little bit influenced by the fact that some of these facilities are all electric heat, but nonetheless, a large component there associated with the lighting. So again, how can we ignore lighting as an element of facility efficiency when it's responsible for around 70% of the total energy consumption? And this is one of the things that we use when we're talking to cultivators to go, look, you may or may not be into LED just yet, but how can we not at least have the conversation with this sort of result? What about greenhouses? Anybody want to take some guesses on what the split of energy consumption in a greenhouse might be? HVAC? How about this? So substantially less energy use to lighting, right, because we're supplementing natural light, and a heck of a lot more energy use on the heating and the fuel side. So that first question that we asked, which was, are greenhouses substantially more efficient, or do they use substantially less energy than indoor? Not in this data set. What we found in this data set was when you consider all fuels, they are within about 10% of each other in terms of total energy use, and also relative to production, because we're kind of looking at everything relative to production as a metric to normalize to. So this does not necessarily agree with a lot of the national literature on the subject. But again, this is not speculative. This is very straightforward, simple data and analysis that we've done here. So for this data set, we are extremely confident that these are the numbers. And again, this helps us focus on, well, what do we look at? What are we trying to do at a given facility? Are we trying to impact its carbon footprint? Are we trying to reduce energy? Are we trying to save energy costs? Because while natural gas might be a big percentage of your consumption, in this particular location at least, it's a fraction of their operating costs. They're still spending way more on electricity than they are on fuel. So a little food for thought as we proceed in terms of what is the data actually showing us, and how do we improve our understanding of these facilities. And in my opinion, it's through more data, right? We can't really figure out what's going on here until we look more carefully, until we get more data. And as Derek said, the power score was extremely helpful as we reviewed this data set. And the more data that we can get into power score, the more that people are publishing and sharing this data, we can really start to understand what is going on in these facilities and how do we better optimize these facilities. And this is a picture from my daughter's theater last year. We did Alice in Wonderland, and I just thought it was a pretty picture to end with. So I'll leave it right there. Thank you.
All right, thanks, Nick. So we're going to have one more poll now for Brian's presentation, but I was wrong I thought that more light equals more yield. So if you were wrong about any of those, I would encourage you to stand up. Come on, please. Anybody? I know that some of you were wrong. There we go. Come on, join us. You learned something. Yeah. Okay. All right, this is the next poll. So what do you think is a bigger factor in the climate impact of cultivation? Is it the amount of energy used in a cultivation facility, or is it the electrical grid mix and the fuels that they choose to use on site? So it's looking at about 80-20. So 80% of folks are choosing that the grid mix and the fuels that you choose are going to make a bigger impact on your climate footprint of a facility. So with that, I'm going to have Brian join us and have his presentation brought up.
Thank you, Gretchen. I'm Brian Jungers, Senior Manager at ESource, which is a Boulder, Colorado company. Used to be part of Rocky Mountain Institute back in the 1980s and 90s, and then spun off, and we've been our own entity since then. But we really focus on utilities and their customers and energy efficiency, demand-side management, renewables, and distributed energy resources. So I'm going to quickly blaze through a little bit of history on the data and the analysis of energy and climate impacts, some of the backlash from that, talk about the elephant in the room, Evan Mills, as John Morris mentioned earlier, get into him a little bit, and then talk about on the aggregate, what's going on in the public record, what do we know or think we kind of know about the overall total impacts of this industry, and give you some key takeaways from my perspective. So who read Up in Smoke, the 2012 study back in the day? Cool, we got a good number of people. It was really groundbreaking because there wasn't anything in the intellectual literature on this industry yet. It had been behind closed doors, black market, and Evan Mills and Scott Zarabi came out and did a detailed, careful analysis based on a very limited amount of actual monitored data from these residential grow facilities in Mendocino County, and they came up with these numbers, which there was a lot of pushback from the regulated industry saying these numbers are inflated, this is not representative, but the reality is that no one actually came and replicated their study down to the line item, and so they were never really refuted. And it was intended as a call to action to say, hey, we need to regulate this industry. We need to have policies in place so that energy efficiency is incentivized. We need to help growers be as efficient as possible. So it was a fairly benign, noble intention to start, but it led to this really kind of crazy media frenzy, right? Did everybody see that? 3 of these are real headline articles, and 3 of these are from the last 6 months. So this is not by any means over, and almost every article that comes out quotes Evan Mills and his 2012 study, and they also often refer to the fact that the city of Denver, about 3 or 4% of Denver's energy use is for the cannabis industry. And so I wanted to dig into that a little bit, but first I wanted to let you all know Mills is not done. He recently sent out a draft of a chapter that he intends to publish in a book about policy, or a collection of papers. And I got news for you all. It's not any better than his 2012 study. In fact, it's much worse. He does not do any new detailed engineering analysis or energy analysis. He points to other analyses, including one that I assisted with from New Frontier Data and RII, saying that they're not rigorous enough, that they lack intellectual rigor. He essentially says that greenhouses are just as bad as fully indoor grows, and that all growing should be done outdoors. We are optimizing the suboptimal, and that it's outdoor cultivation or bust. Nothing else is really acceptable. I have lots of issues with this, and I could talk for half the day about every issue I have with this, but essentially, Evan is becoming something of a sensationalist with this piece in particular. He doesn't really give any consideration of industrial conventional agriculture as a baseline. He only compares to residential and commercial building use, not to industrial, which industrial and conventional ag are much better benchmarks and baselines to consider. And that's just the tip of the iceberg. There's a bunch more, but I'm going to move on. So yeah, there's lots of reasons why we're all doing this, why we're looking at indoor agriculture and controlled environment agriculture, and why we care. If there weren't good reasons to do it, there wouldn't be an industry and we wouldn't be investing all these efforts. So it's kind of silly of him to do this because he's not taking a lot of feedback and improving his analysis. He's just kind of doubling down on a somewhat limited perspective, and I don't think he knows very much about agriculture, unfortunately. So let's look at Denver. So Denver, 3 to 4% of energy use in the city of Denver is going to the cannabis industry. But this is the retail facilities, this is processing, extraction, like the whole 9 yards, right? And if you've been to Colorado, if you live in Colorado, you know that it's not just Coloradans that are consuming cannabis in Colorado, right? I mean, when I've talked to folks there, something like half of the sales in some of these facilities are for out-of-state folks. So it's a lot of cannabis tourism. And as the United States changes their policies, this is probably going to change. But they've published a lot of their energy use data and also the production data and sales data. And so I went and compared Mills' efficiency, production efficiency numbers to what I think the production efficiencies actually are in Denver. And Mills would have said that you could only produce about 100,000 pounds in Denver based on how much energy, like the upper end energy use I have in that range. But the actual sales are like almost 3 times that. So people are obviously more efficient, and the data that Denver has shows that growers are becoming more efficient over time. Now, if we drive up the road from Denver to Boulder, Nick did a great job at already talking about this, so I'm not going to belabor the point, but I mostly just wanted to look at the carbon intensity of the growing happening there. So they report a little over 100 pounds CO2 per square foot of cultivated space in Boulder County. So that is largely because it is a lot of coal in the grid mix there in Colorado, right? So I was part of a study with ICF that we did on behalf of the government in British Columbia. And we found numbers were very different. Brad Queen did a DSM evaluation on behalf of County of Boulder. Some folks have probably seen this. I think the most interesting thing that came away from that study was simply that a lot of growers are not getting any sort of signal back from their energy use because they are master metered and they're not sub-metered. So if you aren't measuring what you're doing, there's no way you're going to be able to really effectively and consistently improve upon that. So just getting folks metered and having the energy use data coming back to them, huge step in the right direction, right? But from the BC study that I was part of with ICF, what we found was really interesting is that the Canadian cannabis growers were less efficient. Whether it was warehouse or greenhouse, they were less efficient than the US growers. And we had data from well over a dozen different data sets and facilities from all over the world. We had data from Europe, data from North America, US, Canada. So across the board, on average, the US growers were more efficient, but the climate impacts were much lower in BC. And it's simply because it's mostly hydro, right? So they don't have any coal in their mix. So even though they're less energy efficient, their climate impact is lower. So yeah, if you guess that the amount of energy you use has a bigger impact on your climate footprint than where you're located, largely that's not the case. And so we actually found that the greenhouses had higher CO2 impact than the all indoor warehouses in BC. So in that climate, and it's mostly because the climate impact is natural gas driven, right? It's because the heating from these greenhouses is really making up a significant portion of that climate impact. So just want to encourage everyone to go out and read the best practice guides if you haven't already. They're free, they're available on the website. I participated in the lighting technology TAC to produce the lighting guide, and it's great. And I hope that we can get out to more growers in the future. So a few takeaways. I think the only way we're really going to be able to fight negative press like what came out following Evan Mills' study is to do our own very critical analysis and publish it and get it out there. We can't just hope that it'll go away because it hasn't gone away, and I think it may actually even get worse over time. So yeah, if anybody wants to publish any studies with me, let me know, reach out. Happy to. Yeah, good. ACEEE. Let's do it. Thank you.
So the 20% of the room that guessed energy consumption is a greater contributor to climate impact, please stand, dance. No one's standing and dancing. It's like they want audience participation, but they don't want to participate. So, all right, this is our next one. 6 gallons of water per plant per day is a good rule of thumb to run with. This is a number that's been said to me in many places, so just curious, who thinks it's good? Where did 6 come from? Okay, fine, nobody's gonna have to dance with this one. All right, I'm gonna welcome Ted to the podium now.
Hi everyone, my name is Ted Grantham. I'm a professor at UC Berkeley, coming from the Department of Environmental Sciences, Policy, and Management. I'm a bit of an outlier here in that I don't work on energy, I work on water. And to date, I've mostly been focused on outdoor, not indoor water use. But I'm super excited to be working with New Frontier and RII on a water report that I think will address both the indoor and outdoor aspects of cannabis cultivation. I think another area that we have in common is an awareness that the lack of data and lack of good data has been an enormous barrier to our understanding of cannabis cultivation systems generally, and also a barrier to good policy. And that's really the approach that I'm coming from as a research scientist at UC Berkeley. And can share a little bit about what we're doing at the UC Berkeley Cannabis Research Center, and then tell you a little bit about our water work specifically. So about 2 years ago, a group of faculty on campus met who were interested in cannabis, and this included anthropologists and wildlife biologists, hydrologists, land use scientists, lawyers. And we recognized that there was a real need for better peer-reviewed scholarship around cannabis, given the importance of this crop to the economy, all of the policy debates happening around cannabis, and to the potential environmental impacts. And so we realized that by working together, we could really help advance some of the underlying science to address these needs. And our approach really builds on not just pure research, but also as engagement. So we work through UC's Cooperative Extension Network to work with farmers, policymakers, regulators, other academic entities to really create a space for dialogue among growers, among industry, and other interest groups. So our focus is quite a bit different, I think, than some of the other UC research centers that are focused on cannabis, in that we're really interested in understanding and studying cannabis as an agricultural system, not as a drug or a medicine. So we don't focus on the medical and public health aspects of cannabis in California. Rather, we focus on things like agricultural production practices, environmental impacts, the policy setting, and really the community level social impacts of cannabis production, which to date has largely focused on the North Coast, but we've been expanding our footprint to other parts of the state. In terms of our water work, the story is actually a little bit similar to the story that Brian mentioned, in that some of the concerns over water use have really been, I think, sensationalized in the media, and there hasn't really been great science to support our understanding of how water use by cannabis, primarily outdoor cannabis growers, could be affecting the environment. There's a lot of anecdotal evidence from raids on trespass grows or illegal grows from different parts of the state of poor water management practices. Here on your left, you see a kind of a pump perched precariously over a stream, diverting water directly from a stream. The photo on your right shows a stream that's been sort of dug out and kind of diverted into a large pond that's supplying a farm. And so when enforcement agencies and the media witness practices like these, it rightfully does raise alarm bells. But the question remains: how reflective are these practices of the broader grower community? And these are really the questions that we wanted to address. And we had some really basic questions, right? And it's pretty remarkable to us when we kind of looked at the literature that these questions haven't been answered. Where do cannabis growers get their water, and how much water are they using? Fortunately, through the passage of Prop 64 and some of the regulatory programs that have been developed to develop a legal cannabis market, we're actually getting new data from growers on their water use. And the results that I'll be showing today are from a data set that was developed through a regional regulatory program that started in 2016, and it basically reflects data from grower community in this region in the 2017 year. And these data include information from about 1,000 farms. It includes information like the size of the cultivation area, the type of the cultivation area, whether that's fully outdoor, mixed light, or indoor, and includes water sourcing, input to storage, and water applied to plants. So our first question, where are cannabis farmers getting their water? They rely on a variety of sources, including groundwater wells, streams, springs, and some rainwater catchment. And when we look at the relative proportion of use, we see that the vast majority of farmers are relying on wells. And let me just kind of walk you through. Focus on the gray lines first. So this represents about 60% of all growers in the region are using wells. And this dark line part of it means that those users are using more than other sources in addition to wells. So a lot of growers are only using wells as their water supply. We also have a fair number of farmers using surface water supplies like springs, like rivers and streams to meet their needs. Fewer using rain catchments, and this offsite basically represents things like water trucking or municipal water supplies. And so this was absolutely a surprise to us. I think there was an assumption, certainly by the kind of regulator community, that growers were primarily relying on surface water diversions, which is really a huge concern, given that where these grows are, they tend to be concentrated in watersheds that support sensitive species like endangered salmon. And so that's really one of the major environmental concerns driving policy in this region. So the second question, how much water is actually being used? So there's really only one other study that's been focused on outdoor cannabis water use, and this is a study by Scott Bauer back in 2016. And yeah, this was absolutely, I think, a good faith effort to think about what cannabis water demands might mean in the context of water availability and thinking about potential impacts to stream flow in these sensitive species that we care about. And they use this, at the time, this is well before legalization, getting access to this data was very difficult, and so they did communicate with some farmer associations to come up with a rough estimate of cannabis use, and that's where this 6 gallons per day per plant estimate over the 150 days of the growing season came. And so they basically used this water use estimate, applied it to the number of plants they viewed through aerial imagery analysis, and then scaled that up to the watershed to estimate the total demand of cannabis in a watershed relative to supplies. And they studied these little watersheds here in different parts of the state. So through this analysis of these about 1,000 reports, we get a much more nuanced picture of water use. Apologize, this is a little bit difficult to see, but let's first start with water use overall. And first of all, what we see is there's a strong seasonal pattern in water demand. And just if you're curious, this shows liters of water. This is basically scaled to the median farm size, which is about 1/4 of an acre in the region. But the pattern is really what I want to highlight here, because that initial estimate of cannabis water use just basically estimated a constant demand from the start of the growing season to the end of the growing season. The water extraction profile for users that rely on perennial sources like groundwater largely explains this trend that we see here, right? So these are the majority of users that are using groundwater, basically are pumping water on demand to meet their needs. In contrast, growers that rely on seasonal sources like springs, where flows may either cease entirely or become quite low or less reliable, they tend to be pumping water kind of year round. And the reason they're pumping water in the winter is because they're moving that water into storage to use later in the growing season. And for those subset of growers that actually had large water storage capacities like ponds, they had a completely inverted pattern of water use where they're basically getting all of their water in the winter months, filling up those ponds, and have very low demands in the growing season in the summer. Now, this has really important policy implications because under the current state water board regulations, any outdoor grower is actually prohibited from taking water from streams in the summer months. So if you're a grower who relies on streams, you're either going to need to build storage to meet your growing season demands or put in a well. And wells, groundwater, are generally not regulated by the water board under their cannabis policy. So we asked the question, do cannabis growers in this data set at least have enough storage on site to meet their growing season demands? In other words, can they comply with these forbearance requirements? And what we see is that the vast majority do not. And so this basically, again, shows that that for these growers that rely on seasonal sources, they're gonna need to either build a pond, which is can be very cost prohibitive. They're going to have to move onto groundwater, which has its own challenges, or they're going to have to drop out of the permitted system. So just to summarize, this is just really a brief snapshot of some of our water research and our research portfolio broadly. But through this work, we found that wells were the most common source of outdoor and mixed light cannabis cultivation in the region. The amount and timing of water really depends on your water source and the amount of water storage capacity available. And that we found that most farms had insufficient storage to meet state permitting requirements, which could be a really important barrier to compliance for growers that are attempting to enter the legal system. And that's all I have today. Next time I'll tell you about our wildlife studies. We're doing some wildlife camera trapping and looking at how wildlife use farms and around farms. And so this is a cool photo that I'd like to share. Yeah. Thank you.
Okay, so I'm just going to do a couple summary remarks, and then we're going to open it up to Q&A. We learned about energy, we learned about carbon, and we learned a bit about water. And all three of those things are going to be better supported by the new developments that we're doing for PowerScore. So I just wanted to remind folks from the speeches we heard from Nick that PowerScore was used as a baseline for comparison for his Boulder County assessment. Brian has been involved in helping improve PowerScore, and we really hope to see an increased use of utility programs using PowerScore to get the benefit while being able to trust the data integrity and accuracy. And then Ted mentioned how the Cannabis Water Report is a collaboration between Berkeley and RII, and then also that we are going to be using information from these studies and the water-related information to be putting into PowerScore as a baseline so that we can make a baseline for water. And then lastly, as I mentioned yesterday, we're going to be pulling in carbon shadowing for the actual energy sources that people use, to the point that Brian made about mixes, so that we can actually understand what's the carbon intensity of these different facilities based off of the fuel sources that they use, the mix of their grid, and then the choices that they make inside the facility. So I invite folks to pepper us with questions. I have some that I could ask, but I really prefer to get them started out here. Don't all jump down at once. Corinne.
Good morning. Thanks, Nick, for that presentation that you showed on energy. I wonder, with the greenhouses, though, and the data set that you had, can you talk a little bit about the geographical distribution of the data set that you had? Was that all up in the north, any in the south?
Yes, so it was all climate zone 5. B? A? Which one's the dry one? Somebody knows. That's not right. You made that up. Whichever the dry one is, 5A, I don't know. It was all 5A, and an important thing I did not, I pointed out how there was a lot of variety amongst those facilities. There was one commonality, which is that they were all HID lighting. There was not an LED amongst them. That was a mix between HPS and CMH, but that is a important, I think, detail that I left out. Also, you are the first to see that data outside of the reviewers in Boulder County, so you're all very special.
There's a follow-up question from the Slido. How does energy compare between sealed and ventilated greenhouses?
So we see more HVAC use in the sealed greenhouses. You know, they have full-blown HVAC systems, and not only are they dealing with the loads from the lighting, but there's the solar radiation that's helping increase the heat in that space as well. So lighting loads are quite similar, that they're both using, within this sample, all of the mixed light facilities were using some form of threshold control to turn the lights on and off. Energy use was pretty similar on the lighting side. HVAC use was definitely higher for those sealed facilities.
Can you remind us how many samples were in your study?
19 facilities.
Yeah, so I wanted to ask about what, as far as energy reporting and gathering data, like what are some of the challenges of scaling that up? I know some of it's been self-reported, but how do we do that accurately at scale?
Sure. I mean, I think that's a lot of attention of the Power Score is for enough folks to adopt it and it become a standard, and then it helps to set the framework for how energy is reported and and in what format, and so that we can compare directly. I don't know that there's any other standard out there. I mean, individual utilities have AMI data and they're collecting data, obviously, but outside of that, there's not a lot of standardization.
The issue for me is the standardization. In other words, you're tying it all back to either high pressure sodium, and you're not going back to what Mother Nature is doing outdoors. It would seem to me you'd want to look at when you're comparing LEDs or anything else, what's outdoors, what is, and it's not just PPFD in the power range that plants are looking for. And with regards to the standardization of using indoor agriculture as a way to then upscale cannabis, when you look at the almond, it's using 1 pound of water per almond. So when you look at 6 pounds for a cannabis, 6 gallons per cannabis, I think we need to also look at standardization of where we start to do the measurements. And then the slide with regards to the amount of yield going down, these are sentient beings. These plants shut down when there's too much there. So putting more light on it is not going to make it grow. Plus, where do you go 18 hours of light?
Do you have a question?
What part of the world?
I'm sorry.
Yes.
Do you have a question?
Yes. The question is, how do you determine the standards from which you be able to make these measurements? Because they're all over the place, depending on who's presenting.
Well, a baseline has to be drawn somewhere. I think we can all agree. There's baselines that we need for outdoor growing. There's baselines that we need for some of the great, awesome stuff that Ted was presenting on how are people getting water, how are they storing it, when are they using it. And those are folks that are using a resource brought to us by the earth. How people choose to light is not necessarily what I think we're trying to talk about in this panel. And so I think what I'd love for anyone to comment on is, like, how do you make a baseline for an industry that, in some opinions, is unbaselineable?
I've been asked this question many times over the years, and I think that you simply start with what people are doing. To the extent that folks are sharing, and we can have some confidence in the data, you see what people are doing right now, and then you look at the range. This is the low end, this is the high end, set an average, and then start to try to ratchet it down. But the problem is so much data wasn't collected for a very long time for legal reasons, and then isn't collected or reported now for proprietary reasons. And so having faith in the data that's available, it really limits our ability to set a baseline or even talk about setting a baseline. So
I'll jump in on that one as well, because we're doing a baseline study in Massachusetts right now Commissioner Doyle, I need to catch up with you at some point, wherever you're hiding back there. Yes. And it's really challenging, you know, because there is no two facilities I've ever been in are alike. They're all a little bit different, right? So there's just a lot of ways to skin the cat. As I like to say, all that matters is there's one more dead cat. So it's very difficult to set baselines, but within that effort to try to figure out what people are currently doing, we are finding there are certain systems or certain parts of the process that there is a lot of consistency, and it is reasonably comfortable to say, okay, this is standard practice for this technology in this phase of cultivation, but like veg lighting, it's, you know, is it T5s? Is it single-ended metal halide? Is it LED? And we see a wide variety of lighting technologies for that, so it's more difficult to say this is standard practice.
Thanks very much. One question that came up when I first started foraying into doing the literature review of the available studies and what is the baseline, how could you compare X to Y, whether it's HPS to LED or something else. And one of the things that I found with the first studies was the SMUD studies done with 7 Leaves and Amplified Farms, I think. And both of them, the first one didn't control for strain, and then the second one tried to at least sort of correlate these ranges of energy and production based off of strain type. And then I started learning more and basically learned that even strain name doesn't really mean anything in genetics. And you could have green crack in one place, green crack in another. They're totally different plants, different genetics. So having it controlled by strain wouldn't be accurate. So I just wanted to open that can of worms. Is there any way to control by plant so that you're actually comparing apples to apples?
We're just starting a study of that very thing with a cultivator who runs his facility like a lab and is one of the only, maybe the only cultivator I've run into that dedicates a room to a strain. So everywhere else I've ever been, they have a mix of strains in a flower room, and that pretty much precludes the ability to figure out how the strain might impact energy consumption. I'll let you know when we're done if it worked or not.
Yeah, and I'll say exactly the same thing. The folks that are really, really controlled facilities, and they're tracking very carefully genotype, phenotype, chemotype, and they can report on all of that, you know, to a very precise ability. That's when you can start to actually work back to a standardization.
I just want to make one comment on with respect to water and this is broadly with water and energy, that it's still very difficult for the research community, you know, university researchers to actually do these types of studies where one might look at, you know, the various responses of particular strains or cultivation strategies to variation in energy or water applications. We're still prohibited from actually working with the plant. It's still considered a Schedule I drug, and we risk our university funding if we even come, you know, basically in contact with the plant. So I just wanted to mention that we're still a long way away in the research community, you know, publicly funded research community, from being able to ask these, you know, relevant questions. So it's really going to depend, I think, on partnerships with industry, at least for the foreseeable future, to get these data that are so important.
So this is a question directed to you, Ted. I think that I heard you say that there's not regulation on wells for farms, and I'm just sort of surprised about that. There's not a regulation on the number of wells or how deep they go. Could you speak a little bit more to that if I'm that for me?
Yeah, so this is one of the fascinating aspects of California water management and water law, and that we have you know, this strong distinction between the way that we regulate surface water and we regulate groundwater. And only surface water is really under the purview of regulation by the state water board. And you know, groundwater historically has been entirely unregulated. There has been some recent policy changes. There's a law passed during the height of the last drought called the Sustainable Groundwater Management Act that did bring some groundwater into regulation. In the water policy, there is a provision that if it can be shown that, you know, groundwater wells are sort of hydrologically connected to surface water, then they can be sort of considered to be under the authority or jurisdiction of the state. But that generally, there's not really any evidence that the state is hungry to exercise that jurisdiction at this point. I mean, they're just really trying to tackle the surface water issue. So.
All right, I think we're out of. Do you want to have one more?
Yeah,
Okay, all right.
right here. I've been a little bit concerned with the whole format of how this is being presented. And let me give you an example. The terminologies of consumption or use of water seems to be interchangeable as far as it's been used here. And that's decidedly not the case. Now, let me give you a very clear example. If you had an old-time mill operation that had a water wheel and he's diverting a stream over his wheel and that's where he's getting his power to, is he using water? Well, I guess he is, but he's not consuming water. And I think generally the idea is that if you are able to return the water in the same quality that you took it in, then it's not consumed. So the real question, I think, usually is how much water are you consuming, not how much water you're using. Now, in plants, the obvious thing is that they consume very little. They use a lot for transpiration. And the question is what's the significance of that transpiration as far as water use versus water consumption? And that gets integrated back into your climate control, your dehumidification, whether you're reutilizing that water, whether it's in some way been contaminated or something like that. And until we get more precise usage of words and definitions, I think the data will not have much significance.
No, that's a great point, and I completely agree. There's an important distinction between applied water and consumptive use of plants. I think in a lot of agricultural crops, there is a substantial fraction of water that's applied to the crops that is not lost through evapotranspiration, and that could potentially return to the environment. With respect to outdoor cannabis cultivation, the practices that we've seen has primarily been very high efficiency drip irrigation is sort of the standard, where we don't really see any evidence of sort of substantial return flows, or not much of that water is ending up back in the environment, at least not to not in any way that we could actually measure and detect a response in, say, the stream from which these waters are being drawn. So I totally agree. There's a need to get to bring sort of more refinement and nuance to our understanding of crop water consumptive use, and those dynamics. We're not there yet. But I would say for cannabis, at least from our experience in outdoor grows, we have, I think, looking at applied water is a pretty good proxy for consumptive use.
Thank you, everyone, for your questions. Just again, another little plug. We've done a lot of improvements to the water side of PowerScore, and we'd love anybody with water stakeholders feedback on that in terms of what are we asking? Are we asking the right questions? Are we going to get the right information that you would want to know? So thank you all. And I think, what's the next thing? Wonderful. Thank you, Juan Carlos.
Yeah, well, let's give a hand to the panel.